everybody. In this tutorial we're going to talk through some of the more advanced features of the Lightforge profile system. And we're also just going to look through all of the nodes that we haven't covered so far and just give an explanation of what they all do. So we're just going to start down the list here, and one of the important things we haven't covered yet is fixture defaults. So what this does is it allows us to set the default value for an attribute. So if we connect an intensity attribute here, and we want to say, all right, I always want this this value to be a certain value when I don't have anything else set on it. I can use a fixture defaults value to set that. So I'm just going to go ahead and say I want it to set the value to 10,000 when it's not in use. So I'll just go ahead and connect this value node to the fixture defaults node. I'll choose the attribute from the attributes list that I want to use, and now anytime that I have this fixture patched and this particular channel is not set to be something else, it's going to default to 10,000. A really handy place to use this is a lot of lighting fixtures use the shutter to determine whether or not the fixture is in use, and so you have to have the shutter set to a particular value before your intensity is going to work. And so generally speaking, you'd set up a fixture defaults node and set that to the value that the shutter should be at. So that is fixture defaults. Next thing we have, you've already seen the value node. Value 8-bit is the same thing, only it is explicitly 8-bit instead of 16-bit like the value node. A color node allows us to pick a color and output it, which is very useful for lighting fixtures that use like a color wheel, and you want to have the color picker be able to select a specific color. Then the last two nodes within the input-output category are set variable and get variable. So let me add one of each, and I'll show you what they do. So if I take and plug the same intensity attribute into set variable, and then I double click it, and I can set the name to be, we'll just say it's test. Now I can double click on the get variable, set its name to be test, and I'll connect it to the output, and the information sent into set variable is setting a variable in the background named test to this value, and then get variable is retrieving that so I can magically pass information between these two parts of my node graph without them having to be directly connected. So that helps a lot with keeping your graph clean, and you can separate things out into sections easier by doing that. So I'll go ahead and delete those, and we'll move into modifiers. So invert is very straightforward. It takes the value that you pass into it, and it inverts it. So given that we're passing a 16-bit number in here, and 65,535 is the maximum value we can have, it is going to take the 0 value we're doing and invert it, giving us 65,535. If we put this to 100%, input value is maximum 16-bit number, output value is 0. So it just gives us the ability to easily invert that without having to do a couple of additional math nodes. RGB to CMY is very helpful for using lighting fixtures that are cyan, magenta, yellow based instead of red, green, blue based. And the way that you would use this is by using a separate colors node. So I can pass this color into separate colors and it'll give me the red, green, blue component. And then I can pass those values into red, green, blue to cyan, magenta, yellow, and it'll give me the values that are correct for that conversion. And then I could pass those to my fixture output. Let's go ahead and delete that. And then we have combine colors, which will take a red, green, blue value and give me a single color output. And we've already seen what coarse fine does in a previous tutorial, but it will take a 16-bit number and break it out into its 8-bit components. So we'll just use intensity again. And now you'll see I have a 16-bit input here, and then it's giving me the coarse and the fine components of that 16-bit number. Next thing we have is in the logic section. So logic gives us the ability to make decisions within our node graph. So first one we'll look at is if greater. So I'm just going to add in a couple of value nodes here. Okay, so we'll have this be a 1, this be a 2, and we'll do 10 and 20. Okay, so what we're going to do is we're going to take value A and plug it in to the if greater node, and then value B. And what this is going to do is it's going to look at value A and then value B and see if value B is greater than value A. And if it is, then it will output 10, else it will output, I want that to be 20, it'll output 20. And since 2 is greater than 1, or sorry, I have that backwards, it checks if value A is greater than value B. So since 1 is not greater than 2, it's going to give me the else, which is 20, so it's going to output 20. So let me go ahead and delete that, and we'll look at if equal. So now it's going to look and see if value A equals value B, then we'll output 10, otherwise we'll output 20. And since 1 does not equal 2, it's outputting 20. If I change this to be 2, now 2 and 2 are equal, it's going to output 10. So yeah, that's how if equal and if greater work. Then we have closest color and list selection. So closest color is kind of an interesting node. Both this and list selection are used to determine mostly color picking on color wheels. So if I take a combine colors node, and we're just going to go ahead and connect color red, green, and blue. And we're going to plug this into the reference color. And now let's go ahead and add a couple of color nodes. So I'm just going to put one close to red and one close to green and one around blue. So now I'm going to go ahead and plug these three values into the 1, 2, and 3 slots on this. And what this is going to do is it's going to pick the closest color that it can to the color that I'm passing in. So if I pass in red, it's going to look and say, okay, the list item on 1 here is closest to red. If I go to green, 2 is closest. If I go to blue, 3 is closest. So we have the ability to compare colors and pick which one is closest. So if I were actually doing a color wheel and trying to use color picking on it, I would also use a list selection. So now with the index value that I've gotten from this, I can pass that into index, and then we're going to add in a couple of value nodes. And in fact, let me make this an 8-bit value node. And we'll say one of these is 50, and one is 100, and one is 150. And we'll go ahead and connect these to the 1, 2, and 3 slots. So now what this is going to do is it's going to take, if I set this to blue, it's going to look and say, oh, okay, the closest color to our reference color is number 3 on our list. So we're going to pass 3 out to the list selection, and it's going to pick number 3 on this list and give us 150. So we would set the DMX values for each one of the colors that we're trying to set right here, and it would pick the correct value for that color. And it's slightly cumbersome to set up color pickers for color wheels through this, but once you've done it once or twice, it actually becomes pretty easy and straightforward. The last couple of nodes that we have are very self-explanatory. They are just math nodes. So we have add, which adds 2 numbers, subtract, which subtracts one number from another number, multiply multiplies 2 numbers, divide divides 2 numbers, remainder does division between 2 numbers and then returns the remainder, and round rounds the value to a whole number. So that is about all there is to show on the node system for profiles. If you have any questions or anything else I can help you with, just let me know, and I'm happy to help you out. Thanks.